Okay, so I'd like first to thank Jamal because of all kindness and the organization of Netdev. Um, I present today our work on scripting the Linux routing table with Lua. It's a simple use case, but I will show the evolution of our framework for scripting the kernel. So I'll start with a short introduction, then I'll show our original architecture for this framework. Then we'll present the following implementation of this framework and the current implementation. And then I will show this use case on scripting the routing table, and then the final remarks. So the Lunatic is a framework for scripting the Linux kernel with Lua language, right? It's out there since 2008. The first use case we have was on scripting the CPU frac. I'll show a script on that. Then we created an extension for NetFilter for implementing advanced security a network monitoring service for network operators. It's running, I don't know exactly how much routers now, but it was more than 20 million routers a few years ago. We have then implemented extension for XDP to call Lua, and this was running on CDN sites. I will show also some scripts on that. Pedro, that is here, have created a binding for ULP. Actually, Vitor Nogueira worked on the XDP Lua. We have also created bindings for KTLS in the past. And there are some other related work. We have implemented these on NetBSD long time ago. It's on part of the main distribution, where we also scripted the packet filter there. There are other applications on NetBSD, like the debugger, the KALF, that is the security policies for process. ZFS also use Lua in kernel, but not our version. And we have other applications. So why Lua in kernel, right? Mainly because it's a very small language that you can easily embed to add a lot of power to the kernel. It's commonly used on many networking tools such as Wireshark, Nmap, Snort. We have presented these 3 years ago on Netdev some sandboxing techniques that you can restrain the scripts to cause harm to the system. It's not what we are going to talk about today. So, but really, why Lua in kernel? My main answer now is it's very easy to add new things, to create new features, or to prototype features. And it has no toolchain dependence. It's very easy to compile these as a kernel module with the same toolchain you have. And it has a very simplified workflow where you can like have a prompt to script your kernel in real time. So this is our original architecture. We had the Lunatic, the main module, holding the Lua execution states. And then we have bindings, such as for CPU frac. These bindings were responsible for calling Lua, like in CPU frac case, a scripted governor controller for the CPU frequency, and also was responsible to add to Lua some APIs to make the script useful, like such as on the CPU frag case for changing the frequency. And this was supposed to work only on process context by then. So this is an example that I used to run on a very old ThinkPad that was frequently overheated, and it was like the same algorithm, the on-demand governor, but I added temperature uh, to consideration to scale the frequency. So if the temperature was really high, I just decreased the frequency. Then we moved to script the NF Lua, the net filter with Lua, created the NF Lua binding. And then in this case, to speed up our development, we dropped out the framework itself, kept only the interpreter, and the binding was responsible to create the entire script environment for the net filter. It was the same case for XDP. So the binding in this case was responsible to communicate with the user space and also with the kernel subsystem, in this case the net filter or the XDP in the case of XDP Lua. And we didn't leverage the old framework because it was supposed to work only with process context. In this case, we needed to run software interrupt context for filtering the traffic, right? And this is how the scripts on NFLua and XDP Lua look alike. The one on the left was for verify the user agent of the HTTP request and check against a block list. On the right side was used for CDNs on where you have a JavaScript hook generated by the web server, and then we checked these on the XDP Lua side. So we moved now to this new modular implementation based on the old architecture, but now we have a base script environment for extending the kernel as a whole instead of having specific bindings for calling the scripts. So this Lunatic run module, it's like a generic binding that calls Lua script when it initiates. And this Lua script is a Lua script that implements a character device driver, and then this character device driver can receive commands from the user space. And we also have a set of new libraries that the script that you load through the Lunatic driver can access to create new features, new extensions. And this new implementation has created a new structure instead of the simple Lua execution state that we call the Lunatic runtime, that you can select where you gonna run your script, if in process or software interrupt context, and it can adapt accordingly to this. Also, in the previous implementations, we had this asynchronous loading of scripts. Now it's completely synchronous through the APIs we provide for the scripts. And we also made it possible to implement part of the framework itself in Lua. For instance, the driver is made in Lua, and the Lua command on the user space as well. We have some libraries that are partially implemented in Lua, such as the socket library. And now this is how a new kernel script in this implementation looks like. We can require a library, in that case, the notifier chain of the kernel, and we can attach a callback, for instance, on this notifier chain for handling keyboard events. In this case, it's something very simple to parse Konami code. I don't know if you are familiar with this. It's popular in gaming. It's up, up, down, down, left, right, left, right. In this case, Control Alt instead of AB. So once we capture this sequence of keys, we block the input. It's like a keylogger. So if you type the Konami code, it blocks the keyboard input. It works like it's a sort of sysmagic RQ implemented in Lua. So the thing I wished to present on the my full is better is that one. That is a slightly change on that script to create a new device slash dev slash Konami full. And when you type the Konami code, you can print a counter on the device. If you cat on the device, you always print that message. My full is not that bad with the count of how many times you entered the Konami code. We also created a RCU hash table. So if you prompt into Lunatic has an interactive prompt, you can share this information through a hash table, synchronize it through RCU. So in case you were debugging your drive could put some useful debug information on this hash table, and you could print these on the device or use the Lunatic prompt to interactively access this data, also to modify this data and get back on your driver. So the use case we have implemented on this new version of the Lunatic framework is on failing over the internet when the link is down. Think about having your cable router, and when it's down, it routes the connection through your cell phone, like automatic hotspot. To do this, we have a very simple protocol that the nodes that can be alternative routers, alternative gateways, send us our heartbeat with the latency of their connection, the alternative connection, and then the router can elect the alternative gateway. When it detects a link failure, it can send a message to the alternative gateway to enable it. And when the link is restored, it can disable the alternative gateway as well. So to load the service now with the current implementation, it's very simple as typing Lunatic run, the name of the script that should be placed on /lib modules/Lua. So it will look for the script on that direction, similarly to Lua kernel modules, right? sorry, Linux kernel modules. And then it will write this very small chunk on the device, dev lunatic, and the driver will run this script on its runtime and create a new runtime to run the service that runs completely independently from the main lunatic runtime. And this is the service. How it's implemented is actually two scripts. This is the main one that loads these libraries. Firstly, it creates attaches a callback for the notifier chain to be aware of when the link went down, and call this failover function. We have another binding for the routing table, the fib one, the fib library. We use the same strategy of VRF. We create netlink message to configure the fib with our rule. And when it's down, we create a rule and signalize the alternative gateway using the socket library. We also create a new thread with the thread library that's implemented through on top of kernel threads. Create a new runtime to run our daemon. This daemon is only responsible to get the message from the heartbeat message from the nodes. So our final remarks is that now it's way simpler to script the kernel with this new framework. We can develop new extensions directly on top of the framework instead of having the need of creating new bindings for this. The workflow is very simplified right now. We have also new facilities for creating libraries to add more features to this framework, and also to create new features in Lua itself. We could add a new kernel service with only 80 lines of code. And this new environment can interoperate with the other Lua kernel scripting environment as well, such as NFLua, XCP-Lua, even ZFS, who could share the same interpreter. So, thank you if you have questions.
Oh, there's somebody there.
Yeah, just a quick question. So for the gateway was already connected to the phone, like the phone was in AP mode or something like this?
The gateway need to run an app to connect to the...
But how are you doing like the Wi-Fi? Or it was a Wi-Fi connection between the gateway and the phone, or not?
The gateway and phone, yes.
Okay,
Wi-Fi
so
connection.
the phone was pre-connected, the gateway was pre-connected to the phone in AP mode.
The phone is connected to the gateway?
Yeah, already.
To the router, right?
Yeah, to the router.
To the router.
Yeah.
Yes, in the same Wi-Fi network.
Okay.
It's using the same Wi-Fi network.
Okay.
It's not currently using the alternative gateway, like the mobile carrier.
Okay, thank you.
Dave, did you have a question? He's doing. Are you able to do equal cost multipath as well? Like, can you select? Can you do active? And
no, right now it would be possible to implement.
It's possible, right?
Yeah. To implement,
but
it's not implemented.
Yeah,
you can script that by yourself.
Yeah, but it's doable.
Yeah, yes, totally.
I figured. he'll probably have something to say.
It's certainly an interesting solution. Ido, myself, and some others have talked about things like active passive next hops, so that you already load things into the fib table and it's a lookup by lookup. So if your preferred next hop or next hop group is not available on that lookup, it goes to the backup. And then if it comes back online, the next lookup just hits the preferred one. That infrastructure just kind of stalled out because no one's had time to work on it. But this is an interesting way to do it.
Yeah, but right now we can just add simple rules to the fib, right? Because we don't have the interface to. It's not exported to kernel modules to.
Yeah, no,
change
you're having to manipulate
tree.
the fib, and which is going to take some time. There's going to be some latency, and when do you get the signal? When do you update the fib? When are the next packets done? Where what we've talked about in the past was just some built-in infrastructure that you can have a backup next hop or a next hop group, and so you could literally go from an ECMP to a single link failover, or a preferred link to an ECMP failover. And again, it's just on the fly and managed more by like FRR or some routing daemon that has those kind of details.
Yeah. Any more questions? Yes, pretty cool. Oh, actually, I have a question for you. Sorry. We have 5 minutes, that's why. The heartbeat thing, is that something that you would probably you can set it up with your current scripts. You can set it up so that it's just heartbeating both gateways, and then it picks the best for some route, for example, right?
Yeah.
Okay.
And if you see here,
Yeah.
failover.conf is also a Lua script. That's just a table that you can configure these sort of parameters in the protocol.
Okay. Last question. I guess you don't. Do you need to upstream anything, or this could be just standalone kernel module that somebody downloads?
It's a kernel module.
Right.
I would not it wouldn't be a problem to me to upstream, but I don't think to end up in the tree anyway. So I just don't want to.
Yeah. Okay. I guess nobody wants to see Lua in the kernel, guys. Anybody? We can set syscall on it. Yeah.
So we have a special library that is called Lua Data that you can map memory, not only SKB. In the case of NF Lua and XP Lua, we just push it to Lua some segments of the SKB as Lua data objects, and it's completely bounded. You can do anything of parsing or.
Okay, I'll repeat your question. So your first question was, how does NSKB look? Because just for the remote people. In Lua, and I think that was the answer. Yeah. What's your second question? All right.
It's related to this. So basically your memory mapping to Lua objects. Oh, sorry. So your memory mapping kernel memory to Lua objects, and then basically I assume these are very like, you just pass memory offsets at that point and then just write data. Is that what the interface looks like?
Yeah, but for instance, if you want to treat this memory as a Lua string, for instance, you need to copy that memory to the Lua state, the Lua execution state. So you can like indicate the offsets and the size you want to turn into a Lua string to parse these as a string, but you can access in place for numbers, for instance.
One more curiosity. So if I remember correctly, Lua has two modes, right? Compiled and interpreted.
Yeah.
Is this with both or only interpreted?
It's not actually two modes. It always generates a bytecode before executing. So we load it and compile, then we run.
But you load it from user space.
right now we load this small chunk from user space. We write these in the device, right? Using the write syscall. And then we have API to load from the file directly in the kernel. So we load the file in the kernel from the kernel itself, and then we compile it in the kernel.
Okay, yeah, that's what I wanted to know. Okay, thank you.
But nothing. It's possible to pre-compile this, but it won't be portable, right?
Right.
Okay, I know a lot of people are going to go, okay, what has this got to do with Netdev? We're diverse here, okay? It's not just about sending up patches, and we appreciate brave people like Lorival showing up here.
And just one last word. If you think it may be useful to your project or you want to try, please reach me out. I'm totally dedicated to this right now. If you just want to play around with this, it's like a doctor's scheme for kernel development. So let's play together, okay? Thank you.
Thank you, everyone. Thank you, Lorival.